Hello, in this video I will be going through the specific heat capacity calculations. So the original equation, energy equals mass multiplied by the specific heat capacity multiplied by the temperature change. So the symbol for energy is E, mass is M, specific heat capacity is C, and change in temperature is delta theta. So I have written the equation again. Here's an example on the top, and I've rearranged the three equations as well to give what mass is, specific heat capacity, and the temperature change as well. So let's have a look at question number 1. How much energy is needed to raise the temperature of 2 kg of copper from 0 to 10 degrees? This is specific heat capacity of copper is 380. So using the first equation, because they're asking for the energy, E equals mc theta, mass is 2, specific heat capacity is 380, multiplied by the temperature change is 10 degrees. So that's 380 multiplied by 2 multiplied by 10, 7,600. 7,600. The unit for energy is joules. Next, a hot water bottle is filled with 0.8 kg of water at 80 degrees. During the night it cools to 30 degrees. Specific heat capacity of water is 4,200. How much energy? So the temperature change is from 80 to 30. So 80 minus 30 equals 50 degrees Celsius. So the energy will be mc theta. Mass is 0.8 multiplied by specific heat capacity 4,200 multiplied by 50. That gives me 0.8 times 4,200 multiplied by 50, 168,000. So 168,000 joules. If I convert it to kilojoules, it will be 168 kilojoules. Question number 3. How much energy is needed to heat 2 kg of cooking oil with a specific heat capacity of 2000 joules per kilogram degree Celsius from 20 to 120? So delta theta is 100 degrees Celsius. So energy was mc theta 2 multiplied by 2000 multiplied by 100. That would give me 4,000 and 2 zeros. So that's 400,000 joules or 400 kilojoules. Question number 4. Andy has a bath and uses 1,500 gram of water heated from 10 degrees to 30 degrees, 40 degrees Celsius with a specific heat capacity of 4,200 joules. How much energy? So the mass, which is 1,500 gram, is 1.5 kilogram, and the temperature change is 30 degrees. So energy equals mc theta. I'm not writing the delta sign, but it's implied here. So mass is 1.5 times 4,200 times 30 1.5 times 4,200 times 30, 189,000, 89,000 joules, which is 189 kilojoules. Question number 5. An electric kettle supplies 20,000 joules of energy to heat 0.5 kilogram of water. What is the temperature change? The specific heat capacity of water is 4,200. So the temperature change equation is delta theta equals energy divided by the mass times the specific heat capacity, 20,000 divided by 0.5 times 4,200. So 20,000 divided by 0.5 times 4,200, close brackets, 9.5 degrees Celsius. Two decimals is 9.52. I'll leave it at one decimal place. Question number 6. A piece of lead with a specific heat capacity of 126 joules per kilogram degree Celsius is given 5,000 joules of energy to heat it from 20 to 250 degrees. What is the mass? Delta theta is 250 times minus 20 gives me 230 degrees Celsius. The equation that I will be using is M equals, or mass equals energy divided by the specific heat capacity multiplied by the temperature change. So 5,000 divided by 126 times 220. 5,000 divided by 126 times 120, close brackets, 0.18 kilograms. A 2 kilogram metal cylinder is supplied with 1,600 joules of energy to heat it from 5 to 13 degrees Celsius. So the temperature change is 7 degrees. What is the specific heat capacity? Specific heat capacity is energy divided by the mass times delta theta. So 1,600 divided by 2 times 7. So 1,600 divided by 2 times 7 is 14. So let me just put 114.28. 114.28 joules per kilogram degrees Celsius. Question number 8. 201,600 joules of is supplied to 600 grams of water, which is 0.6 kilogram, with a specific heat capacity of 4,200. What is the change in temperature? So delta theta equals the energy divided by the mass times the specific heat capacity. So 201,600 joules divided by 0.6 times 4,200 divided by 0.6 times 4,200, 80 80 degrees Celsius. Question 9, 10, 11 and 12. I'll do the calculations in the space below. I've got 3, 4, 5. So question 9. Becky has a shower and uses 20,000 gram. So that's 20 kilogram of water with a specific heat capacity of 4,200. When the water is applied with 336,000 joules of energy, it heats up to 50 degrees. What is the starting temperature of water? So let's find the temperature change. So temperature change is energy divided by the mass times the specific capacity. So 336,000 divided by 20 times 4,200. 336,000 divided by 20 times 4,200. So the temperature change is 4. That's 4 degrees. Now the starting temperature, what they're asking is the starting temperature. It heats up to 50 degrees. So if the final temperature was 50, it should have started at 46 degrees Celsius. So 50 minus 4 equals 46 degrees Celsius. 46 is the answer. Question 10. A washing machine heats 10 kilogram of water. How much energy is saved by washing at 30 instead of 50? If the starting temperature of the cold water is 16 degrees Celsius, the specific heat capacity of water, okay, so we will have to do two calculations. We are trying to calculate the energy. Starting temperature of the water is 16 degrees. So I'm going to find the energy that is needed to increase it from 16 to 30, and then find the energy to increase it from 16 to 50, find the difference. So E equals mc theta mass is 10 times 4,200 times the temperature difference. If it starts at 16 and goes up to 30 is 14, which is 10 times 4,200 times 14, 588,000 joules, and the other equation is mc theta. So 10 times 4,200 times, what if it goes from 16 to 50? So the difference is 34 degrees. 10 times 4,200 times 34, 1,428,000. If I take from this answer 588,000, that would give me 800 800 840,000 joules. That's my answer. Question 10. A washing machine. No. Question 11. A student heats up 5,000 gram of block of iron. So that's 5 kilogram from 18 to 46. So the difference would be 46 minus 18, 28 degrees here. Transfers 62.8 kilojoules. Multiply that by 1000. I would get 62,800 joules of energy. Calculate the specific heat capacity. So C equals E divided by m theta. So C equals 62,800 divided by 5 times temperature change is 28. 62,800 divided by 5 times 28, 448.57. 448.57 joules per kilogram degree Celsius. Question 12. A 5 kilogram block of iron with a specific heat capacity of 450 joules per kilogram degree Celsius receives 0.03 megajoules. Mega is 10 to the power 6. So that's 10 to the power 6. So 0.03 times 10 to the power 6 is 3 times 10 to the power 4 joules. That's 30,000. Is it 30,000? 3, 1, 2, 3, 4. Yes, 30,000. So, what are they asking for? What is the temperature rise? So, delta theta equals E divided by mc. Delta theta equals 30,000 divided by 5 times 450. Divided by 5 times 450. That's 13.3. 13.3 degrees Celsius. Question 13. Specific when the temperature of 0.25 kilogram of ice cream is increased from minus 10 to 8 degrees, so the temperature change is 8 degrees. The heat supplied is 3000 joules. Find the specific capacity. C equals E divided by m theta. C equals 3000 divided by the mass, which is 0.25 times 8. Let's see. 3000 divided by 0.25 times 8. 1500. 1500 joules per kilogram degrees Celsius. brings us to the end of the calculations. Thank you.